Welcome to Module 07 of 12 of the CipherVibe Cybersecurity for Beginners course. Today, we will make application and API security understandable, practical, and connected to the rest of your learning path. Applications turn identities and untrusted input into business actions, making authorization and boundary validation central concerns. Secure software combines design, implementation, dependency integrity, testing, deployment controls, runtime evidence, and learning. The purpose of this lesson is not to memorize a collection of terms. It is to build a mental model you can apply when tools, platforms, and threats change. We will define the core ideas, walk through a repeatable defensive workflow, examine mistakes that frequently mislead beginners, design useful safeguards, and finish with a safe portfolio exercise. Throughout the course, remember that security work begins with authorization, scope, and evidence. Use the exercises only on local systems you own or environments you have explicit written permission to assess. Pause when you need to. Write concepts in your own words, record observations, and distinguish what the evidence proves from what you are merely assuming. That habit is more valuable than rushing through another tool demonstration. Start with 4 concepts that provide the vocabulary for application and API security. First, broken access control lets a valid or anonymous user perform an action outside the intended authorization policy. Second, input validation enforces type, length, structure, range, and context before data reaches sensitive operations. Third, software supply chain security protects source, dependencies, build systems, packages, artifacts, and deployment authority. Fourth, security logging records important identity, authorization, data, configuration, and administrative events without exposing secrets. Do not study these as isolated definitions. Ask which asset or business service is involved, where the relevant trust boundary sits, which identity performs the action, and what reliable evidence would show that the control worked. Security reasoning is a chain. Source evidence supports an observation. The observation supports a conclusion. The conclusion informs a proportionate decision. The decision has an owner, an expected result, and a way to verify it. When any link is missing, say so. A professional explanation can include uncertainty without becoming vague. For example, a network record may prove that 2 addresses communicated, but it may not prove which human initiated the action or whether the content was malicious. Use diagrams whenever a relationship is difficult to explain in a sentence. Mark identities, systems, data flows, boundaries, and controls. A simple, accurate diagram is more useful than a crowded picture that implies knowledge you do not have. Now turn the mental model into a repeatable workflow. First, draw an application data flow with users, browser, API, services, database, dependencies, and administrators. Second, mark every trust boundary and define authentication and authorization at each sensitive action. Third, review validation, error handling, secrets, dependencies, logging, and secure defaults. Fourth, test an intentionally vulnerable local application only inside an isolated authorized lab. Fifth, turn findings into design improvements, reusable components, tests, and verified fixes. Before acting, define the objective, scope, owner, and success condition. Collect the smallest amount of trustworthy evidence needed to understand the situation. Preserve timestamps and sources so another person can follow your reasoning. Priorities should be explainable. Consider exposure, identity and privilege, sensitive data, business importance, exploit conditions, existing safeguards, reversibility, and confidence. A dramatic label should never replace that analysis. The workflow does not end when a command succeeds, a ticket closes, or a dashboard turns green. Verify the new state with fresh evidence. Check for recurrence and for side effects introduced by the change. Document the result in plain language: what you observed, what you concluded, what you changed, who approved it, what evidence confirms the outcome, and what uncertainty remains. This disciplined loop, observe, interpret, decide, act, Verify and learn appears in every cybersecurity specialty. Understanding failure modes will protect you from attractive but unreliable shortcuts. First, hiding a button in the interface does not enforce authorization at the server. Second, automated scanners miss business logic flaws and can report false positives. Third, verbose errors and logs may expose tokens, personal information, and internal architecture. Fourth, untrusted build execution and package confusion can compromise software before release. Fifth, security gates without useful remediation guidance encourage bypasses. These mistakes often share one cause: confusing an available signal with a complete explanation. A tool can report a finding, a successful action, or a score while important scope, context, ownership, and verification remain missing. Avoid absolute claims. Words such as secure, compromised, fixed, and compliant require scope and evidence. Prefer precise statements such as, "This control blocked the tested path under these conditions," or, "The available records show this identity used the service," but do not identify the human operator. Also resist copying commands without understanding their inputs, outputs, permissions, and side effects. Run one controlled change at a time and record what happened. If an exercise does not behave as expected, that is useful evidence. Stop, inspect the environment, revise the hypothesis, and explain the difference. Good security work is not a performance of certainty, it is careful reasoning under imperfect information. Reliable security uses layers because no single control can prevent every failure. First, enforce authorization on every sensitive server-side action and test negative cases. Second, use allow-list validation, parameterized data access, safe output encoding, and bounded resource use. Third, protect repositories, build identities, package sources, provenance, and deployment approvals. Fourth, use managed secrets and prevent credentials from entering source or logs. Fifth, combine threat modeling, review, testing, runtime telemetry, and incident feedback. For each important risk, ask 5 questions. What makes the event less likely? What evidence would reveal it? Who can contain it? How will trustworthy operation be restored? Who owns the decision and accepts remaining risk? Least privilege applies to people, applications, devices, automation, data stores, and administrators. Access should be scoped, separated, monitored, reviewed, and removed when it is no longer needed. Every important control needs a test strategy. Include representative normal activity, negative cases, misuse, dependency failure, and rollback. A written policy is not evidence that a technical or operational control works. Design for humans. A safeguard that is impossible to use correctly will be bypassed. Provide safe defaults, understandable messages, usable recovery, and clear escalation. Finally, preserve the evidence trail from observation through decision, action, and verification. That history supports investigations, audits, lessons learned, and honest measurement. Finish the lesson by creating a portfolio artifact rather than merely watching another explanation. First, run an intentionally vulnerable application on an isolated local network. Second, create its data flow diagram and identify authorization decisions. Third, review one broken access control path and one unsafe input path defensively. Fourth, recommend code, test, logging, and deployment improvements. Fifth, deliver a short defensive review linked to recurring OWASP risk classes. Keep the work bounded. Use local systems, fake data, and environments you own or are explicitly authorized to assess. Record the objective, environment, actions, observations, screenshots, errors, conclusions, and limitations. Useful measures for this topic include critical application coverage, authorization test coverage, escaped defect rate, managed dependency coverage, and recurring defect rate. A useful measure has a precise definition, a trustworthy source, an owner, a review frequency, and a known limitation. Ask someone unfamiliar with the exercise to review your artifact. Can they understand the system, the evidence, the decision, and the remaining uncertainty without watching you perform the lab? When the answer is yes, you have created more than notes. You have evidence of professional reasoning and communication. Continue with the next module in the Cybersecurity for Beginners playlist and use the complete written curriculum at CipherVibe.com/news. CipherVibe is operated by Cloudsectech LLC. This video is general education, not legal, compliance, financial, or incident response advice. Never access, scan, or test a system without its owner's explicit written authorization.